So we're going to sketch this polynomial function, and the first thing we want to do is try to figure out what the end behavior looks like. The way to figure that out is to take a look at what would be your exponent for your x's. If we multiplied this out, now we don't have to multiply it out to know that we'd end up with an x squared in there somewhere. And then we also have this x that we had have to multiply. So we're going to end up with at least an x cubed. We also have this negative on this x, so we will end up with a negative x cubed to start with. So that's going to tell us what our ends are going to do. If we have an odd exponent, the ends are going to do different things. One will be up, one will be down. If it is an even exponent, then the ends do the exact same thing. They either both go up or they both go down. So this one's odd, so the ends are going to do something different. Now, this, you have to figure out which one goes up and which one goes down. So we take a look at what sign we have. This one's going to be negative. So what this thing is going to do is like a negative slope. If we were to draw a straight line, a linear equation, and that had a negative slope, it would go downhill from left to right. Well, this is very similar in that it will go downhill from left to right, but it may do some weird things in between. So we don't know what it's going to do in between yet, but we know that it's going to go downhill from left to right. And I'm a visual person, so I'll draw a picture. That means my left hand side, this side, is going to go up, and my right hand side is going to go down. So that's how we'll answer this first part of our question in order to sketch the graph. Another thing that we're going to want to do in order to be able to sketch this graph is to find our intercepts, our x and our y intercepts. We'll start with the y intercept. And these we do exactly the way we have always found x and y intercepts, even when it's a linear equation, is we plug in 0 for x to find our y-intercept, and we plug in 0 for y, or f of x in this example. F of x and y mean the same thing. We plug a 0 in there to find out where our x-intercepts are. So I'm going to write what we have here. Now if I substitute 0 in for my x's, then I can find out what my y-intercept will be. Well, I'm going to have, not that the negative makes any difference here since it's 0, but I have 0 times 4 squared. So it really doesn't matter. I'm going to get 0 for an answer. 0 times anything is going to be 0. So that is what f of x or y, because remember y and f of x mean the same thing. You could just rewrite this as y equals, and it would be the same. This is just, f of x is just function notation for that. So now we have answered two parts of our question, trying to figure out how to sketch this thing. Now we want to know what our x-intercepts are. So we use 0 for the y, and then we write down the rest of it and solve for x to find out what our x-intercepts are. Now, since this is already factored out, we can just set each of our factors equal to 0. So we've got, and don't worry about the negative, but we've got negative x equals 0 there. We've got x plus 4 equals 0. And we actually have two of those. See, it says it's squared. I could list it out twice, but there's really no reason to list it out twice because you get the exact same answer for both. But that is something to keep in mind, that you will get the answer to this one twice. So x has to be 0 or x is negative 4. Those are our x-intercepts. This thing is also going to ask you about the multiplicity of your x-intercepts, and it'll ask you based on, because it doesn't want to give away the answer for your x-intercepts, but it'll say which one is the furthest left, and that would be the negative 4. So if it asks you for the multiplicity of the leftmost x-intercept, that one's your -4, and in this case, it shows up twice, so the multiplicity is 2. How many times does it show up? How many of those do you have? And then the one that's furthest to the right on your x-axis would be the x equals 0, and that one only shows up once, so it's got a multiplicity of 1. Multiplicity of 2, multiplicity of 1. So the next thing I think it will ask, if I recall correctly, is for you to do a test value. So it will give you some number for x and ask you to plug that in. It may state it as, have you find, let me select my pen, f of, say, 4. If it asks you to do that, then you just plug in 4 wherever your x's are. And I can't remember what this one does. I haven't worked all the way through this particular problem, so it may give you a different number, but that's what you would do in that case. So in this case, we'd have -4 times 16, and then we'd have to square it, so you can multiply that out. You can stick that in your calculators. One of those type of problems. So, but that's how you work through these. And at some point, I think that it will give you some choices of graphs. What does the graph look like? So based on the information that you've put in, you should be able to pick the correct graph. Another problem is the same type, except that this one's not factored. So we'll end up having to factor this one to be able to find our x-intercepts. But otherwise, it's been multiplied out. So we can find our end behavior from this. We have another odd exponent. So the ends will do something different. Since there is positive out here, this x cubed is positive, then it's going to go uphill from left to right. Whatever it does in the middle, it's going to go uphill. So it will start on the left-hand side down, and it will work its way up on the right-hand side. So that's how you figure out your end behavior. Next, to find our y-intercept, we just have to plug in zeros for all the x's. So 0 cubed plus 3 times 0 squared minus 16 times 0, which all of these parts give us 0. So we're left with a -48, which is our y-intercept. To find our x-intercepts, we are going to have to factor this thing. Because we set this equal to 0. And then once we factor it, we can set each factor equal to 0 to find out what our x-intercepts are. Now, since we have 4 terms here, the way to do that is to factor by grouping. So we want to factor out something that these two things have in common, and then factor something that these two have in common, and then hope that our factors, that what we have here on the left and what we have on the right, factor so that they have something in common. So on this side, we can get an x squared. They both at least have an x squared. If we factor that out, x squared times x would give us our x cubed back. And then x squared times +3 will give us our +3x squared back there. Now both of these on the right hand side here, these terms are both negative. So I'm going to factor out a negative because what I would really like to get out of this is an x plus 3 factor. So I'm going to take the negative out, and 16 and 48, those are both divisible by 16. So I can take out a -16. And 16 times 3 is 48, which is what we hoped. So -16 times x would give us our -16x back, and -16 times +3 will give us a -48. So we are in good shape because we have this as part of each of these now. So we can factor that out. It's something that they have in common. So I will write it out front. the x plus 3 factor, and then I'll write a set of parentheses that has whatever I have left, which in this case I have this x squared and I have a minus 16. So I'll write down my x squared minus 16. Well, that I notice is the difference of two squares. It's the difference of x squared and 4 squared, because 4 squared is 16. So that one factors, the difference of two squares factors as, that one is x minus 4, x plus 4, or vice versa, it doesn't matter. And when you multiply that out, if you did the FOIL method, you would see you don't end up with a middle term there, but that's a special type of factor. So now that we have it all factored, we can set each of these factors equal to 0, find out what our x-intercepts are. So in this case, we need a negative 3 to make that one 0. We need a positive 4 to make that one 0. If we set it equal to 0 and solve, that's what you would get. And for this one, you would end up with a negative 4. So you have your x-intercepts there. So we've got our y-intercepts, our x-intercepts, we have the end behavior. We'll do a test point probably with this one as well. So whatever they give you for a test point, just plug that in for the number they give you in for x. Evaluate your function to see what the y would be. And then you'll be able to pick which graph that they give you is the one that goes with this. If they ask you for multiplicity on this one, each of these only show up once. So the multiplicity for each of these x-intercepts is just 1. I hope this helps. Let me know if you need more because I'll be happy to do another video.